I thought I'd take a look at my holographic duality in my magic ghost number cubes. Well, as you can see right here, this is just a square. The duality between the squares and cubes of my magic ghost number squares and cubes. So right here, it has it's a square, it's a plane, and a 10 goes into 10 one time. And we can see 3 and 7 going across equals 10, and 5 and 5 going across or diagonally equals 10. And so, but when you move on to make it make it a hyper, the square works out. It still has a proportion of 30 to 30. If you include the 10 right here, the ghost number 10, and the other side 10, 30 equals the outer ghost number 30 that's created when you use commutative property to pull the central ghost number out and put it in with the operations on the outside of the outer layer. So the square still has even in its hyper form, it still has its one proportion, 30 into 30. This is a regular square, 10 to 10, 1 and 1. And a duality of a normal cube, the 30 would be the three-dimensional counterpart to 10, the central ghost number, in a normal magic ghost number cube. When the zeros are in front and back, or in back and front to suppress the third dimension. But and they follow along with the non-dual or the not directly dual. They follow along with the proportions. 30, if you consider 30 the outer ghost number. 3 times into 120, it's 4. And it's 3 right here, and it's 4. And then non-dual semi-super, it's 30 goes into 180 6 times. 30 in non-dual super-hyper, 30 goes into 248 times. I'm a little bit messy there. And these are the backbones to the, or the foundational to the super-hyper. But addition cubes in their ground state would have only 1 and the rest zeros. And so if this was a square, it would still, the three-dimensional counterpart to the dual to the square would be 3. And but it would be indirect again, and it would still follow the hyper, super, semi-super, and super-hyper. I didn't even draw this because I knew where it was going. This is the hyper, this is the semi-super, and this is the super-hyper, and that would have required a backbone. But this is addition in its ground state, and it still follows the rules laid out for the more advanced cubes. But the multiplication cube in its ground state, and it would be all 1s for the primary numbers, because any 0 would make it disintegrate all down to zeros. The central and all the other, the outer ghost numbers would be 0. So this is in its true ground state, and it didn't follow along with the hyper and the semi-super and the super-hyper, because all it spits out is 1s. There's no proportion going from 3 to 6 to 4 to 8, and so on like that. So multiplication cubes in their ground state don't follow the rules of the hyper, semi-super, and super-hyper. But an addition cube, in actuality, that's not its ground state. That's just the lowest number you can have to produce another number that's not like it, or a third of it. But the ground state, the identity of an addition cube is 0, so it would be all zeros. The identity of a multiplication cube is all 1s. And I'm sure if this was all zeros, it wouldn't have advanced on to these either. It would just remain 0. And then the same thing that happens with the multiplication cube in the ground state. And that's its true ground state. If we have a single 0 in there, it would all crash down to zeros, the central and the outermost numbers. So 1 is the multiplication identity of this cube. And this is this was just one of the images you've seen earlier or just a little while ago in the paper, and it follows the hyper and semi-super and super-hyper proportions, and it has since it brings the commutative property all the way across, brings out the central ghost number, then the third dimension is no longer suppressed. So the third dimension comes back in these hyper forms, and you could probably subdue them in a regular normal magic ghost number cube, and you can get the basic holographic dual square. It's in its right proportions, like the normal one is, but the cube doesn't